Okay, now it's recording. Okay, figure 1 shows a stream of water hitting a wall at a height of 8 meter with a velocity of 40 meter per second at an angle 35 degree below the horizontal. Okay, determine the initial velocity of the water as it leaves the nozzle. So as you can see over here, it asks for initial velocity. So again, this one is about a vector. Okay, velocity is a vector, so you need to give two things. You need to give magnitude and also direction. Okay, that means you not just give the value, you should also give the angles. Understand? The angle theta, the direction. Understand? Okay, so initial velocity means he want this lah. He want this initial velocity. And what's the direction? Oh, sorry. Second. Okay. So he want the direction. That means the angles. The angles theta. Okay. So this one should be above the positive x-axis lah. Okay. So how do we continue? Okay, we have this final velocity v, angles. This one should be sy lah, yeah. So one thing we have over here, we have sy. It is positive 8 meter. Yeah. Origin is origin is, we take origin as here lah, yeah. Origin. This origin, and the final point is over here. Yeah. This is the initial point, and this is the final point. Okay. So the final point is 8 meter above the initial. Okay, 8 meter above. So that's why sy is positive. And then we have this 40. 40 is final velocity v. This final velocity v. So we can resolve this v into two component. We can resolve it into two component. Understand? So we have v. We have 35 degree. So this Vx is actually, because this V is 40, so Vx is 40 cos 35. 40 cos 35. And then what about the Vy? Vy is downward, you see? Direction downward. So it's negative, huh? So it's negative. Direction downward. So you should put it, negative 40 sine 35. So far so good, class? Okay, understand?
Understand, sir.
Okay, so we have this. Okay, and of course this U also has the own component, yeah. It has the ux and ux and uy. Okay. Okay, so how are we going to do this question? So we should actually try make two component, yeah. Separate into two component, okay. Separate into two components, write everything here, then easy for us to get the data. First thing we know is ax always 0 because constant velocity. Ay is negative g because free fall motion. Okay, and then what we have is we have sy. Yeah, we have sy. Sx we don't know. Yeah, Sx don't know, but Sy we have a positive 8 meter, and then we also have a Vx. Vx is 40 cos 35. Maybe you can okay, never mind. And then Vy is Vy is negative 40 sine 35. Okay. What else we have? Okay, so he asked us to find initial velocity. I think it's easy lah. Huh? Initial velocity. That means we need the u, ux and uy, right? Remember that for x component, the velocity in x component is constant. So actually this one vx equal to ux, correct or not? Vx equal to ux. If you don't believe, maybe you can vx equal to ux. Okay, because you know v equal to u plus at, you know, x component, yeah. Because ax is 0, so yeah, 0. So vx equal to ux lah. Okay, constant velocity. So we got the ux already, right? We want to the question asks for initial velocity. That means it asks for what? It asks for u. Okay, asks for u. So we already get the ux component. Now we need the uy. Okay, so our ux is equal to vx, yeah, which is 40 cos 35. Maybe you can calculate 40. Make sure in degree, your answer in, no, your calculator in degree. So I calculated is 32.766 meter per second, yeah. Okay, and then uy, how to find uy? Easy lah, yeah. We have 4 things, you see here. V square equal to u square plus 2as, isn't it? V square equal to u square plus 2as. All these are y component, yeah. All these are y component. So that's why easy. If you write all the information, you put in 2 columns, easy for you to see. X component we have what value, y component we have what value. Then easy for us to determine the equation. Understand? Equation. Okay, so this one is negative 40 sine 35 square, and then okay, I just continue from here, and then we need to find the uy actually, and then ay is negative g. Ay is negative g, so we can write negative 2. G is 9.81. Okay, the negative go outside lah. Huh? Okay, and then sy is 8 meter. Okay, we can find our uy. Let's calculate. Negative 40 sine 35. Okay, negative 40 sine 35 and square, and then plus 2 multiply 9.81 multiply 8. Okay, so we get this, and then we square root the answer. I got 26.141. Okay, meter per second. Okay, so I got ux and uy already. So now I got the, you know, ux and uy. So I can find the u. Okay, I can find the u. So I got the ux and uy. Yeah, I got the ux and uy. Ux and uy. Okay, so my
nothing.
so my ux is 32.766, and uy is 26.141. So I can find, you know, my u, understand, my u, and then I can find my direction. So how to find the magnitude of u? Just ux square plus uy square. Calculate, yeah, let's calculate. 32.766 square plus 26.141 square, and Square root answer. Okay, it is 41.8. Have I done anything wrong here? Any wrong steps here? Okay. So please tell me if I done anything wrong, yeah? You are the check and balance, you understand? You are the check and balance.
I think something is wrong with the UI, sir.
Really?
Yes.
Okay, so which part is wrong, yeah? 40 sine 35. Okay, let me calculate again. 40 sine 35. And then I square the answer. And then I plus 2 multiply 9.81 multiply 8. Answer. It's correct. Yeah, it's correct. Maybe we will check the final answer, yeah, later on. Yeah.
But the schema say 19.21, sir. I also got the same, sir.
Oh, really? So somewhere is wrong over here. So which part is wrong, yeah? Which part is wrong, yeah? Do you write the same value over here?
My displacement is -8, sir.
Oh, really? -8.
Yes.
Hitting a wall with why negative? This one, the final is above the origin, what?
I also don't know, sir. I just put -8, sir. Maybe my concept wrong.
Because you see he because the displacement is above what? Above. Hit a wall, you know. This one also is this one from the ground to the top. Yeah, from the ground to the top. So it should be you know, above the origin. The ground is the a bit confused about the diagram, yeah. A bit confused about the diagram, but he hit the wall, right? Hit the wall. The wall is above the origin. Yeah, above the origin. So it should be positive lah. Yeah, it should be positive. Anyway, I continue first. All right. Okay. So right. So let's what's the direction? Okay. So this is the magnitude. About the direction. The direction. So let's direction is uy over ux. Oops. So anti-tangent later on. Okay. So so it's 26.141 divided by 32.766. Okay, and then anti-tangent. Okay, 38.58 degree above positive x-axis. Okay, anyway, this is the answer I got. Okay, above the positive x-axis. About because your displacement is positive. Why displacement is positive? Okay. So I think should be this answer, yeah. Okay. Yeah. Okay, should be this answer. Okay, let me stop recording for a while.